Hi everyone, I'm Patrick Arlt, and I'll be joined by Gavin Rickemper and Jacob Weselkowski. We're going to talk about building web apps with open source mapping APIs. And the three that we're primarily going to cover today is we're going to take a look at Leaflet and the Mapbox MapLibre GL libraries, and then we're also going to take a look at OpenLayers. And the reason we're kind of focusing on these three is that these are the three most common of the open source mapping APIs. They all kind of share smaller modular footprints. They all have fairly simple, straightforward APIs, and they all have big ecosystems to choose from with lots of plugins, lots of open source support, and things like that. Now, there are a couple reasons, though, not to necessarily choose these if you're building an application. I think it's important to get this out of the way right now, is these don't have support for a lot of the more ArcGIS centric concepts. So you're not going to find things necessarily like web map support or built-in support for ArcGIS identities, like authenticating ArcGIS Online users. And they don't have extensive support for some of the more specific service types. So if you're looking for something like stream layer or image layer or dynamic map layers, they don't necessarily support all the types of services, but there are ways to get them to use some of your hosted data, and we're going to go over that later. And then the last bit is, especially in the case of Mapbox GL and OpenLayers, there's no direct integration with any of the ArcGIS REST APIs, although you can use REST.js. So primarily what we're going to talk about today is we're going to talk about basic mapping. We're going to talk about routing, geocoding, and demographic data using those kind of core location services. And then we're also going to talk about vector tile layers, and specifically rendering vector tile layers and styling them. So this is really kind of where the main focus of this is going to be. Now, there are a couple additional things that are part of the Esri Leaflet plugin. Esri Leaflet does support feature layers, and over the last year got support for the same kind of heavily cached tiled feature layers that the ArcGIS API for JavaScript supports. And it also has some rudimentary support for working with map services and image services. It also has things like a pre-built geocoding control, and it has support now for vector tile layers. So there's a lot of additional things in Esri Leaflet that do make a lot of sense and open up more choices for building applications while still keeping the footprint modular and small. So kind of to summarize, you need to think about the capabilities that your app is using for this. Do you need the tighter integrations? Do you need some of the UI widgets that are part of the JavaScript API? Do you need 3D? Do you like the 100% kind of WebGL rendering, or do you want a really small, light footprint? Do you need access to that open source ecosystem? If that's a requirement for you, then the choice should hopefully be clear between choosing one of these over the other. And then some additional questions to ask is, if you're building an app that utilizes authentication through ArcGIS Online or ArcGIS Enterprise, and you're really heavily making use of that identity to access items and content and share things, if you need web map support, those are both great reasons to use the JavaScript API. But if you're only consuming the basic location services, then these are really going to be a good option for you, and it might be worth considering using one of these open source APIs. So we're going to get into some demos now, and Jacob is going to start us off with some demos in Esri Leaflet.
So what we'd like to do now is take you on a tour of using Esri Leaflet with ArcGIS location services. Through this, I'll walk you through a few demonstration tutorials to give you a taste of what's possible. First off, let's start with something straightforward, a Hello World demonstration. Here we'll just create a new Leaflet.js map, and we'll add a vector base map layer to it. So first we have to start off with obtaining an API key and inserting it into our code, deciding which ArcGIS style basemap we want to use. In this code sample on line 4, we can create a Leaflet JS map with an initial location and zoom level. And then on lines 8 through 10, we'll add a brand new vector basemap layer using that API key and add it to the map. We have a fully interactive Leaflet JS map with that vector basemap layer. Let's take a look at the code ourselves. In our HTML document, we start off with loading Leaflet from CDN, both its CSS and JavaScript requirements, as well as Esri Leaflet JavaScript files. Down in our custom script tag, you can see that it's waiting for us to insert our API key in order to be able to load that vector basemap layer. So let's do that. Give it a moment to rerun the code, and there we go. While we're at it, I'll start the default zoom a bit further out, maybe change our location. And let's try something else. ArcGIS : imagery. All right, hello world. Let's do something slightly different. What if we want to show a custom vector tile style? We'll use an API key. We'll start up another Leaflet JS map instance with that initial location. And in this case, we'll add a custom vector tile style. Here's an example of that. And let's open up the code. We're still importing the Leaflet files, the Esri Leaflet plugin files, and our script tag isn't too different. We need that API key, we need to start up the Leaflet JS map with a default location, and supply a vector basemap layer, this time with a custom identifier. So we'll put in the key again, let that load. Great, but with my developer account, I created my own style. Made some quick modifications to come up with some interesting colors here. I also changed the font with some really quick edits. I'll grab that unique ID, jump back over to my code pen, and paste it in and let the code refresh. There we go. Now we're having fun. Okay, so let's add a little bit more here to our user experience. Let's say we need to build a mapping application that lets your users search for an address. The Esri Leaflet plugin also has a geocoding control that you can add to a Leaflet JS map. In this code snippet, we're creating a new search control. We're providing several constructor options, including the providers array. In this case, we're just adding one provider, and that's the l.esri.geocoding.arcgis online provider, which requires an API key. Then we add it to the map, and later we can listen to the results event for the search control. And then we can handle those results and update the map with what we want it to do. Let's take a look at that one. Here the map's default location and zoom is set to Sydney, and I've got my geocoding control available here in the top right. Let's try it out. Sydney Opera House. There's some suggested results. I'm going to choose the first one. The map zooms in after that event fires, showing us coordinates and the name and the address of what was found. This time we'll just scroll down and look at the code. We perform some of those basic boilerplate actions, such as setting our API key, the base map we'd like to use. We construct a Leaflet JS map with some options, add that vector basemap layer. We also bring in the Esri Leaflet geocoder code for this to work. And here's that expanded version of that brief code snippet we looked at earlier, where we create a new search control with some options, including that ArcGIS Online provider with an API key added to the map. And then we listen for its results event. to show us that custom pop-up information and to move the map to that location. Let's search one more time. Okay, I'm hungry for lunch, so let's look for some pizza around here. Okay, let's do something a little bit more advanced. Let's find service areas. So here we'll use Esri Leaflet again, and we'll also rely on the ArcGIS REST.js library to help us calculate service areas. In addition to the things we've done before, we'll use an API key to let ArcGIS REST.js help us with authentication while we calculate service areas. So what we'll do is for every Leaflet.js map click event, we'll use the service area function available in ArcGIS REST.js. And for that click event location, we'll handle the network response and update the map. Let's take a look. So everything begins with the map click you saw in the code snippet. So we'll click. And now we've calculated service areas. So we have a marker here showing us where we clicked, and we have these service area polygons that inform which area can be reached in a given driving time from that location. And as each polygon gets bigger, we have a visual indication of the increased driving time. I'll click again to generate new service area polygons. One more time. Okay, let's look at the code ourselves. So we'll import a leaflet, Esri Leaflet, and ArcGIS REST.js to help us do all these things. This code example is waiting for that API key. It's establishing a base map and a Leaflet.js map, some layers to handle the source point and the service area polygon results. It's also reusing our API key to create an authentication object with ArcGIS REST.js. And finally, we're establishing the map click handler. So let's put that API key in, let the code run again. Okay, here we are with the ArcGIS navigation base map centered around Bangkok. Let's take a look at that map click handler again. When the user clicks, we clean up any previous features on the map. We add the source point at that click location. And then finally, we make that API request with the help of ArcGIS REST.js using the service area module. Then once we get that response back, we'll use the Leaflet GeoJSON layer to display the GeoJSON polygons that are available to us in that network response. And we'll set some fill colors based on the polygon attributes. So I'll click, wait for that response, and render 3 polygons on the map with different shades of blue. Okay, one last demonstration for you. Let's query for demographic data, again with ArcGIS REST.js and Leaflet. Let's look at the live demo. So again, we're relying on a map click handler to fetch additional demographic information. Let's go north a bit, see what we can learn about Glasgow. I click roughly in the center of town. I get additional information for 1 mile search radius, including population, number of males and females, and average household size. Now we'll take a look at the code again. We'll be loading Leaflet, Esri Leaflet, and ArcGIS REST.js. Setting those initial properties, such as the base map we'd like to use, the API key, and of course, wiring up that map click handler. So map click will run the get demographic data code. When that runs, using the lat long location, we'll pass it into ArcGIS REST.js's query demographic data function. Then when that network response comes back to us, we'll set the pop-up content. Let's do one more comparison. I'd like to know the difference between Warszawa and Krakow. So I'll zoom in a bit. I'll click somewhere towards the central business district, Here I see for a 1 mile search radius a population of about 87,000 or 88,000 people. Let's go down to Krakow. Here we have about 66,000 people. So as you can see, there's a lot we can do here with Esri Leaflet and the ArcGIS location services, and we're just scratching the surface.
So I want to go over some of the Mapbox GL, MapLibre GL technology, and we'll get to why this is kind of a split section in a minute. So most of what I'm going to talk about you can find at developers.arcgis.com/Mapbox GL JS. Also, all of these links at the bottom are going to be links to the demos. So I want to get started. Shortly before we launched this, Mapbox split their open source offering from the 1x version, which is currently 1.13, and they released their 2x version, which I believe is something like 2.1. And the 2x version of Mapbox GL JS is not actually open source. It requires an API key from Mapbox to work, and they're no longer actively developing their 1x offering. And this has kind of led to an open source fork of GLJS, which is called MapLibre, led by MapLibre. And so the demos that I'm going to show today are really for the 1x version of Mapbox GL JS, or potentially for MapLibre GL. This hasn't been tested, but the first version of MapLibre is just a release of Mapbox GL JS 1.13 with some of the Mapbox specific stuff stripped out. So that's why there's this split. Going forward, we're going to focus a little more on MapLibre and Mapbox, the 1x series, to try to make sure that our documentation is compatible with those. So the first thing that most of you will want to do with an application like this is we're going to want to get something like a basemap and some basic services set up, and that's essentially what this demo is right here. So in this demo, what we're going to look at is we're going to look at just building this little application, this little geocoder. And this essentially is a pretty basic application, but this is something that just kind of shows the services and shows how the integration works. So this loads Mapbox GL JS. We're also using ArcGIS REST.js to do the interaction with the geocoding API. So we need the base request and auth libraries as well as geocoding. There's some basic CSS styling in the demo, which is important. And then we do use the new API key implementation. So this is new as of the end of January. API keys are publicly consumable strings. You'll see similarities to other platforms here. You can go and register a key, and then it's your responsibility to monitor it for usage. And we see that we're using the new style service. So this is the new service, and this is going to request type equals style, and this returns a Mapbox GL JS compatible style representing the navigation style in ArcGIS Online. And if I zoom out, you'll see I get the nice navigation style that we have, and then we can implement the geocoding control. And the geocoding control is really just a class with an onAdd method, and we can add it to the top left. It has some HTML in its template. And when that geocoding button gets clicked, we can use our ArcGIS REST.js to format the request to send it, and we get the response back, and we can use that to interact with the map. So this is essentially the most basic demo. We create a new map. We point it at our navigation style with our API key, and that returns a valid style that we can then render. So going forward, I'm going to spend quite a bit of time talking about hosting and querying your own data. So in this example, you can see I've run this query here, and we can add a second query, and that'll select shapes from data that we've actually published to the ArcGIS platform. And this works in largely the same way. So the data that we published is going to be in a feature layer, and we're going to use ArcGIS REST.js's feature layer tools to get access to that. So we have the same setup. We have an API key. We're using the streets base map. We create a GLJS map. We're going to use the built-in GL drawing tools. We're going to add those. And we're going to add a source. And in GLJS, a source is essentially any source of data. So we are going to add a source of GeoJSON data, and that's going to be an empty feature collection. And then we're going to essentially add other layers for our drawing tools. And then we're going to instantiate this parcel layer that we're going to fill with the results of our query. So we're going to query the parcels intersecting or within our shape, and then we're going to create an empty kind of layer for that. And when the map loads, we're going to add all of those additional pieces. And then when we actually create a new shape, we're going to use Terraformer, which is another open source offering from Esri. We're going to turn that into a corresponding ArcGIS geometry, and then we're going to use that geometry with REST.js to actually do the query. So we're going to take the geometry that we draw, and we'll turn that into from GeoJSON, which is how GLJS gives it to us. We're going to turn that into an ArcGIS geometry, and we're going to pass that to execute query. Execute query is going to query features from the feature layer that we have hosted in the ArcGIS platform. And we're going to get out all those geometries, and we're going to get our parcel source, and we're going to set the data to the response. And this works because we allowed you to query GeoJSON out of the platform. So we'll request GeoJSON. We want all features intersecting this polygon that we just drew. And then when we click on these, we can actually see that we can find out that that's irrigated farmland. So that's some basics of hosting and querying data. So we have a layer in the background. We can use that underlying service, and we can query it for data. Now, you can also create and host vector tile layers inside of the ArcGIS platform, and this is important because that's mostly how a library like GLJS operates. So this is actually composed of 3 different layers. We actually have a layer for the trailheads, we have a layer for these trails, and then we have a layer for these park polygons. And you can composite and combine these just like you would regular vector tile layers inside of Mapbox GL JS. So this is an API key that we're using. We also have a custom map style, so you can also customize the look and feel of these base maps. So this is a custom style, and I'll go into how I created that in a second. And you can actually just use the identifier for that style on the style API, just like you would an identifier like in the previous demos for ArcGIS streets. So that you can substitute in your custom identifier for that. You'll get one when you create your custom style. And then when we load the map, we want to add the parks and open space source. So we're going to start from the back, and we're going to add our parks and open space. We're going to point it to a source of data, and this source of data is a layer that we've got published in the platform. And I'll go into how we've created that in a little bit. And then once we have the source of the data called parks and open space, we can add a layer that refers to a specific layer inside that source. In this case, there's a layer that's parks and open space, and we can define how we want to paint that layer according to the GLJS API. And then we can actually just repeat this process for the trails. We need a data source for the trails. We need a layer to represent the trails when we add those, and then we add a second for the bike trails. You'll see some trails have this dotted line inside them, and that we're using that to represent bike trails, so we can actually add the layer that looks at the same source again. And then for our trailheads, we want to have the kind of standard hiker icon, so we can get that off of the ArcGIS CDN. So we'll add that as a icon that GLJS can understand. And then we'll add our trailheads layer, and we'll tell our trailheads source and layer to reference that icon. Now, one key thing here is that this data that I'm accessing is actually private. So starting with the last release that we did at the end of January, if you have an ArcGIS developer account, you can use an API key to read private data. That's currently in beta, and we'll be announcing a pricing model for that later. If you're an ArcGIS Online organization, you don't have access to this, and to access private data, you're going to need to do the usual process of doing OAuth 2 to get an ArcGIS identity, and then going through the process that way. But in both those cases, you're going to get a token, and you can pass it to the tiles to get the private data. So how did I set all of this up? And the data actually comes from one of our tutorials, which is import data as a feature layer, and you can find this in the Mapping APIs and Location Services guide. So if you go to the developer site, you go to Documentation, Mapping APIs and Location Services, and then drill down into the data chapter. We actually make this data available to you, and we'll tell you how to import it. And once you import it, you'll end up with a whole sequence of layers. So this is the Trails GeoJSON file that is part of that data. And that you can, when you upload it to the developer site, you can import it and find it. And when you do that, you can then generate a feature layer. And once you have a feature layer, that's actually backed by a service that you can query the data for, which is what we saw in this demo. But if you want to get it as vector tiles, you can actually publish it as vector tiles. And if you go into the details of your layer, you can publish a vector tile layer. And you can do things like select which fields you want to publish, and you can use this to create vector tiles. So this is the vector tile version of those trails. And if I go into view details, you can see that we actually give you kind of a default style, and this is exactly what I'm copying into my parameters to plug into Mapbox GL JS. And I'm tweaking the rendering a little bit, but this gives you the basics. And this source layers is where you can actually go to see what the different layers inside this vector tile data source is. So in this case, we only have a single source layer called Trail 0. And to manage access to this, because you can see it's private, it says authentication required, I actually created an API key that is allowed to access this content and items. And it's got access to 4 right now. It's got access to the basemap, the parks, the trails, and the trailheads. And it also is what I'm using for basemaps, and it also has the ability to do geocoding and routing. So this kind of wraps up all of that access and permissions in one API key. So this is how you can kind of get access to private data if you have a developer account. Now for the custom basemap, there is a new set of tools that we released last year. If you want to create a new vector basemap layer, you can go into Vector Tile Style Editor, and you can start actually customizing some of our existing basemaps. And when you do this, you'll get a item ID that you can substitute in for your style. And so when I save this, I get an item ID, and I can actually take this item ID over to my map and use it. So if I go back, I'm going to share this publicly. I'm going to grab that item ID, and I can plug the item ID in as my style. And now we have a brand new basemap style. So that's how you can kind of go end to end, customizing everything, hosting your data in ArcGIS platform, rendering it out in GL JS. And so just to wrap up, the raw queries to endpoints are rate limited, so there's some special tooling in some of the APIs like the JavaScript API and Esri Leaflet that reduce the query volume for public data. Mapbox and OpenLayers don't have that. So if you're building an application that you expect to be fairly high volume, you're going to want to publish that as a vector tile layer. And really, the kind of preferred workflow should be publishing as a vector tile layer. And then you can also leverage ArcGIS REST.js for your service interactions.
OpenLayers is a JavaScript library for displaying map data in web browsers. There are many mapping apps out there using OpenLayers, and if you're already using OpenLayers, you might want to be able to use the Esri open source mapping APIs with the OpenLayers library. I'll go through how to do that here. To create a basic Hello World app that includes an Esri vector tile layer base map, first we include the OpenLayers library by importing the CSS and JavaScript. We also import the OpenLayers Mapbox style library. This library, sometimes shortened to OLMS, allows adding a vector tile layer with a style specification, which is what we'll get from the Esri endpoints. The key code for the app is here. We create a new OpenLayers map passing the ID of the DOM node we'd like the map to be placed into. Then we set the initial center and zoom of the map with the setView function. Then we build up the basic map style URL using the API we get from developers.arcgis.com, the basemap ID string indicating what style of basemap we want, in this case the streets basemap, and put both of those strings into the URL hitting the basemaps API.arcgis.com endpoint. This URL will return back a vector tile style JSON that we can pass directly to the OLMS library, which will add it to the map. So let's see that in action. Here's a CodePen code sample with that code in it. As we mentioned, we've included the CSS and JavaScript for OpenLayers and included OLMS. We've created a div that contains an ID of map, which is where we'll place our map. We've added some basic styles so that the map takes up the full area of the window. And in our JavaScript, this is the JavaScript we just looked at, being sure to place a valid API key from developers.arcgis.com, and we're placing our basemap ID and our API key into that URL. Now we have a working map. I can zoom in, zoom out, and we've got that map in place. We could change the basemap style to say topographic, and the basemap is immediately changed. So let's take a look at adding a feature layer. The next thing we might want to do in our OpenLayers map is to add a feature layer to the map. Feature layers in ArcGIS Online can be returned as GeoJSON, so we'll use the OpenLayers vector source and vector layer to display GeoJSON. Switching over to our CodePen. After the base map is added to the page, instead of putting this console.log, we'll go ahead and use the ol.source.vector to create a new vector source based on the URL of our feature service. Here's the feature service URL, and the key piece is this f equals GeoJSON, which is going to export or output the features as GeoJSON. We then take that source and put it into an OpenLayers vector layer and simply add it to the map with the add layer function. Now we can see all of those points that are added to the map. For our last OpenLayers demo, we're going to do some routing. This sample will be a little bit more advanced. We'll add a button to our map. We'll wire it up so that when the button is clicked, we will take two random points from the points layer and get a route between those 2 points using the ArcGIS REST.js library and show the results to the user. This will involve transforming data from WebMercator to WGS84, as well as showing data in multiple layers, the points as well as the route result layer. So let's jump in. First, we'll import the ArcGIS REST.js library. We'll import the routing and auth packages. Then we'll add a button to the UI that will allow us to click to generate the route. Next, we'll add some CSS styles to place the button into the top right-hand corner of the map and add some other styles. So now we've got a button up here. Finally, we'll work on the JavaScript. We'll add a click handler to our button so that we have a function that we know will get called when the button is clicked. We want to loop through the points, showing a route between two different points each time the button is clicked. So we'll create a variable called I that will track which index of the points we're currently on. Now if we open our developer console, when we click the Route Me button, we can see our I index variable increasing, which is just what we want. Next, we'll take care of the initialization. We want to create a new layer to hold our route, and when the points layer loads, we want to store those points in a variable we'll call allFeatures, so that we can loop through those points when the button is clicked. So here we're going to call a function called addRouteLayers, and we'll populate allFeatures. To define out that function, we'll go to the top, addRouteLayers creates a new vector layer. We're applying some styles, and we're adding it to the map. Next, let's add the code that actually calls the REST API to get the route. This will be in the button click handler, back down here where we created that. Now this code is a little more complex. We're first clearing out the route layer, and we're creating the start and end coordinates to save for later. We then use the ArcGIS REST API, passing our API key, and calling the solve route, passing our initial coordinate and our end coordinate, as well as our authentication. That then calls the REST endpoint, resulting in a response that we can convert to GeoJSON, and then we display that GeoJSON in a vector layer and set the route layer source to display it. All that code means that when we click Route Me, if we zoom out, it'll find two of the random points and find a route between the two. Now we have a problem here that the points might be close together, so it's hard to tell where the route is being placed. What we can do next is zoom to the route when I click the button. So let's do that here. Back up in the initialization, we'll add a listener so that when the route layer changes, it gets the extent, it checks if it's a valid extent, and if it is, it sets the map using the getView and setView functionalities. So now when we click Route Me, it'll zoom to my route. Today we've shown you how to use the open source mapping libraries with the ArcGIS platform. Whether you're building with Leaflet, Mapbox GL JS, or OpenLayers, you can use Esri basemaps, feature layers, geocoding, routing, and other geoservices all within your current app. Esri has plenty of resources for learning about these topics. For Esri Leaflet, there are tutorials at developers.arcgis.com. You can find the documentation for Esri Leaflet out on esri.github.io/Esri Leaflet. GeoNet community for questions and answers over at esriurl.com/community/esrileaflet. And the code is open source on GitHub, where you can find that. It's at github.com/esri/esrileaflet. The Mapbox GL JS resources include tutorials out on developers.arcgis.com and a community on GeoNet for questions and answers. OpenLayers also has tutorials on developers.arcgis.com, as well as question and answers on the GeoNet community. Thanks for listening, and please provide feedback for this session by clicking on the session survey link directly below this video. Thanks.